Welcome to the Explainer. Today, we're diving into the AI tools category to take a close look at SwanLab. And specifically, we're going to unpack exactly how it streamlines the notoriously fragmented AI training tracking workflow. If you've ever found yourself totally lost in a sea of disconnected experiment logs, well, this explainer is going to be incredibly relevant to your daily work. We've got a clear roadmap for this explainer. We'll start with the ML tracking friction, meet SwanLab, explore its architecture and workflow, look at integrations and log types, compare cloud versus self-hosted options, and finally, discuss production capabilities and limitations. Let's get right into it. Section 1, the ML tracking friction. I want you to really think about this for a second. How difficult is it right now to accurately pull up an old model run from 3 weeks ago, or to share those exact results with your teammates so they can compare it against their own baseline? When your tooling is disjointed, these seemingly simple tasks suddenly turn into massive productivity bottlenecks. We all know the painful progression, right? You start with simple print statements in your terminal. Then, as experiments get more complex, you move to writing custom CSV loggers. Eventually, you realize you need visual graphs. So you end up wrestling with the overhead of tools like TensorBoard, painstakingly copying event files across different machines. Every single step in this progression adds tooling overhead that fundamentally slows down your AI development. Section 2, meet SwanLab. This brings us directly to the solution we're exploring today, which is engineered to remove that exact friction from your workflow. The crucial takeaway is that SwanLab addresses this fragmented process by providing everything in a single unified package. It's an open-source platform that doesn't just log your experiments, it provides an interactive dashboard for visualizing those results. It actively monitors your system hardware, and it natively supports team collaboration. It's essentially built to be the central hub for your entire training pipeline. What's genuinely impressive about SwanLab is this number, 50. It integrates with over 50 mainstream frameworks right out of the box. So whether you're using PyTorch, Hugging Face transformers, or specialized large language model fine-tuning tools, it's designed to fit seamlessly into almost any stack you might already be running. Section 3, architecture and workflow. Under the hood, the architecture here is beautifully simple and modular. It relies on 3 core components. First, there's the Python SDK, which acts as a sensor that you embed right into your training script with really minimal changes. Then there's the backend, which is the brain, receiving and storing your streamed data. Finally, there's the dashboard, acting as your monitor for interactive web-based visualization. Because these components are separated, nothing in your actual training loop logic has to change. Turning that SDK sensor on in your code is remarkably straightforward. It literally requires just these 3 minimal lines of code. You initialize the project, you pass your hyperparameters to the config dictionary, and you log your metrics inside your training loop. That completely replaces the complex, messy overhead of those custom loggers we talked about earlier. Section 4, integrations and log types. As I mentioned, the framework support is massive. You can seamlessly hook it into PyTorch, LLaMA Factory for model fine-tuning, or verl for reinforcement learning. But beyond the software frameworks, it comprehensively monitors your hardware utilization at a system level. What really stands out is that it tracks not just standard NVIDIA GPUs, but it has specific adaptations for specialized and emerging chips like AMD ROCm, Huawei's Ascend NPU, and Ijaluvitar GPUs. And when it comes to the actual data, it doesn't just log plain numbers or scalars. It natively supports a massive array of rich media. You can visually inspect model outputs epoch by epoch using logged images and video GIFs. If you're working with language models, it supports text logs with full markdown rendering. And for more specialized AI research, it even visualizes complex 3D point clouds and biochemical molecules. It really adapts to the specific visual needs of your AI domain. Section 5. Cloud versus self-hosted. For enterprise teams, functionality is great, but data privacy is absolutely paramount. So you basically have 2 main paths here. You can choose the zero-setup SwanLab Cloud for instant, out-of-the-box multi-user collaboration. Or if your organization works with highly sensitive training data, you can deploy it fully self-hosted via Docker or Kubernetes. This gives you complete data privacy and air-gapped capability, meaning your proprietary metrics never, ever leave your own servers. If you do go the enterprise self-hosted path via Kubernetes, which was fully rolled out for production in late 2025, you'll need to manage some specific infrastructure dependencies. To run the backend components reliably, you are looking at needing Kubernetes version 1.24 or higher, Helm 3.9 plus, and standard robust databases like Postgres, Redis, and ClickHouse. You'll also need an S3-compatible storage solution like Minio for your media assets. Section 6. Production and Limitations. For teams handling heavy, distributed workloads, SwanLab recently added some incredibly vital features in early 2026. They introduced a parallel mode where multiple worker processes can simultaneously log to a single experiment. They added baseline comparison, which allows you to pin a specific run and automatically calculate the percentage differences of subsequent runs against it, making ablation studies super efficient. And to handle the UI load of these massive hyperparameter sweeps, they rolled out Lightning Board v2, a high-performance view specifically designed for rendering thousands of charts without lagging. However, to be completely objective in our explainer today, we have to talk about constraints. It is a newer tool compared to established platforms like MLflow or Weights and Biases. And as this insight accurately notes, while English documentation is available and improving, the primary development community right now is Chinese language. So if your engineering team relies heavily on massive pre-existing English forums or Stack Overflow-style support for quick troubleshooting, that's a practical constraint you definitely need to consider before migrating your entire stack. So I want to leave you with this thought. As modern open-source tools like SwanLab mature and make experiment tracking and visualization essentially effortless, the friction inevitably moves elsewhere. What is the next big hurdle or bottleneck in your team's AI workflow that you need to optimize next? Thank you for joining me for this explainer, and I hope this gave you a really clear, structured understanding of SwanLab.